Okay, so this one, solving another 3 by 3 linear system. We're not going to do any comparison. We're going to try to get this transformed into some simpler and simpler 3 by 3 systems where there's a 2 by 2 subsystem inside, and then down to a point where we know one equation with one variable, finding out what that variable, what number that variable equals. So the easiest part here, we've got a 1x in both of those. So we could get a 1x and a negative 1x to cancel between equations 1 and 3. Just because that was the thing that we got to cancel first in the previous example when we went from system 1 to system 2. Even better yet, we could use that positive 1z to cancel the negative 1z in both equation 2 and 3. So my working equation or my focus equation is equation 1. Don't even need to do any multiplying to get the z's to cancel out. Got 4x plus 4y. The z's have canceled, and that's equal to 12. Notice that these 4's going to 12. It would be totally legitimate to multiply everything on both sides, all terms, both sides, by 4. Sorry, 1/4. It's like we're dividing everything by 4. So x plus y equals 3 as my new equation. Call that my fourth equation, I mean. Well, okay, fifth, because this was my fourth, and I transformed this. Okay, so now add 1 and 3. Again, no multiplication of either equation needed to get these z's to cancel. Now we have 2x minus y equals 6. Two equations where I've had x canceled out from both, z, so we only have x and y as our variables. Put those together along with our working equation 1 to come up with our new subsystem. That has a 2 by 2 subsystem inside it. In fact, I got really lucky here. Without any more multiplication in this case either, add these right away and the y's will cancel out. So now I know that 3x equals 9, and dividing both sides by 3, x equals 3. Back substituting, if x is equal to 3, then we have 3 plus y equals 3, which implies y must equal 0. And when we've got the values of two of the variables known, put both of those into equation 1. Three times 0 is 0. 0 plus 3 is 3. We could have just covered that up and said 3 plus z equals 5. Subtract the 3 from both sides to get z equals 2. And again, if you have to write that as an XYZ ordered triple, we'd be talking about 3, 0, 2. You can plug those back into the original 3 by 3. I neglected to talk about that in my first example, but you'd have 3 plus 0 plus 2 is 5. Yes. Doing the multiplication, 9 plus 0 is still 9. Minus 2, that is 7. 3 minus 2 times 0, 3. Minus 2 is 1. So the order triple 302 does check. See you in the next one.